In this video, we will cover how to solve quadratic equations by the square root method. And so to be able to use the square root method, if you think about your quadratic equation being your ax squared plus bx plus c equals 0, to be able to use the square root method, you must have b equals 0 slash have no b term. It's the only time that this method is applicable. And so to be able to do this, once you realize that you have no b term, step number 1 is to isolate the squared term. And then step 2 is to take the square root. Now, what this is showing you is that you can solve these by factoring, which we did. This was example 1b, where we had no b term. You can use the square root property instead and get the exact same results. So let's use the square root property here to find the real and complex solutions. Again, complex solutions means your I. So we're going to get some imaginary numbers here. So you've got 2 steps: isolate the squared term and then take the square root. This is already isolated, so we're good here. This is the only one here where we actually don't want it in standard form. Everything else I need in standard form, we have everything on one side and equals 0. This time I need x squared equals something else. So the square term's isolated. So the next step is to take the square root. And that's because if I have x squared here, well, the opposite operation to squaring something is to take the square root. So the square root of x squared is x. And then for this one, I'm going to put this in my calculator. This is a perfect square. If I do the square root of 121, we get 11. Be careful with this though. This is only half of my answer. When I take the square root of something, I need to remember that I have the positive and the negative of that number. So this isn't just 11, it's plus or minus 11. Okay, I know I get 2 answers because it's squared, but when I plug this in, I get this answer. 11 squared is a positive 121, but when you do negative 11 in parentheses squared, you also get 121. So when you take the square root, remember that what comes out isn't just the positive of that, it's also the negative. Right? Same thing here. We need to isolate the squared term. So we're going to do that by moving our 45 over by subtracting. So x squared equals negative 45. I've isolated my x squared. So now the opposite of squaring is to take the square root. The square root of x squared is x. And then now let's break this down. I'm going to use red again. The square root of negative 45 is the same thing as the square root of 45 times the square root of negative 1. Well, the square root of negative 1 is my I. So let's break down 45. That's 9 and 5, and 9 is 3 and 3. My 3 comes out, my 5 stays in. So this equals plus or minus. The 3 comes out, so does the I. and then that 5 stays in. So x equals plus or minus 3i square root 5. Let's get this x squared term isolated again. We'll do that first by adding over our 40. So I've got 2x squared equals 40. My square term is still not isolated because that's 2 times x squared. I cannot take the square root here because 2 is not a perfect square root. So let's divide both sides by 2. And we get x squared equals 20. Now I can take the square root of both sides. So the square root of x squared is x. The square root of 20 needs to get broken down. That is 4 times 5, which is 2 times 2. My pair comes out, and my lonely 5 stays in. This is not negative, so there's not an I with this problem. So this is 2 square root 5. And what did I forget here in my answer? Hopefully you recognize that plus or minus. So my answer is plus or minus 2 square root 5. Now these kind of look different, but they are the same. This is still my squared term. I've got x plus 1 quantity squared. So my squared term is isolated. So to get rid of this squared, I'm going to take the square root of both sides. The square root of x plus 1 quantity squared is x plus 1. Just like here, the square root of x squared is x. It's what's getting squared. X plus 1 is being squared. And so that square root and squared cancel. And you're left with x plus 1. Then we have the square root of 18, which can be broken down. That is 9 times 2, which is 3 times 3. So I have some 3's come out. So this equals plus or minus 3. And our lonely 2 stays in. I have not finished solving for x, so go ahead and finish solving for x. So this is, we're going to subtract 1 over. And so this is plus or minus 3 square root 2 minus 1. Now, while this is the correct answer, I personally like these two flip-flopped. And so I'm going to write my answer as -1 plus or minus 3 square root 2. If you write your answer this way, that's still completely correct. Okay. Then E, isolate your squared term. I'm going to do that by moving my 11 over to the other side of my equation. So I've got x minus 5 squared equals 11. Now that my squared term is isolated, I can take the square root of both sides. So we're left with x minus 5, and I don't need parentheses around that. We're left with x minus 5 equals, when you break down 11, that's a prime number. That's only at 1 and 11. That's the only way you can break that down into multiples. And so this will stay as plus or minus the square root of 11. If it can't be broken down at all, it's going to stay. And if you break it down and you don't get pairs, it's also going to stay. So if you have something like the square root of 6, when you break that down, it's only 3 times 2. You don't have a pair of anything. So that can't be broken down. That will stay square root 6. And then let's get x by itself, and we'll do it by adding our 5 over. And so we get x equals, you can do plus or minus the square root of 11 plus 5, but I'm going to go 5 plus or minus the square root of 11. And then our last one here has all of the bells and whistles. Let's get the squared term by itself by subtracting that 24 over. So I've got x plus 3 squared equals negative 24. To get rid of this squared, I'm going to do the opposite operation, which is taking the square root. My square root and square cancel, and I'm left with x plus 3 equals, let's break this down. This is the same thing as the square root of 24 times the square root of negative 1. There's my I. 24 can be broken down as to 4 and 6. This is 2 and 2, so there's a pair. And this is 2 and 3. I didn't even realize that when I did that up there. So that's going to stay square root 6. So this becomes plus or minus, my pair comes out 2, the I comes out, and then multiply 2 and 3 back together to get the square root of 6. And then your last step is subtract this over. So my final answer is negative 3 plus or minus 2i square root 6. If you want to write that backwards, that is okay. If you want to do just like this, negative 2i square root 6 and then minus 3 at the end.